Assalamu alaikum. Myself, Dr. Ansari Farzana with Zama, Department of Chemistry, J.A.T. Arts, Science and Commerce College for Women, Malegaon. Welcome all of you. In previous section, we have seen that two fundamental law of photometry, Beer's law and Lambert's law. That means absorbance is directly proportional to path length and absorbance is directly proportional to concentration. If we plot a graph of absorbance against concentration, a straight line passing through origin should be obtained. But sometime there may be a deviation occur from the straight line. Some curve obtain concave upward direction and sometime the curve obtain concave in downward direction. Such like in this figure, concave in upward direction, concave in downward direction. However, sometimes plot is observed absorbance versus concentration does not give a straight line and there is a deviation from linear relationship and apparent failure of Beer's law may ensure. When the actual absorbance is greater than expected, the system shows resultant curve which is concave in the upward direction. Then it is called as positive deviation. When the actual absorbance is less than expected one, the system shows the resultant curve which is concave in downward direction. Then it is called as negative deviation. The positive and negative deviation from Beer's law can be arises due to certain factors. The shape of absorption curve and thus lambda max value may sometimes changes with change in concentration of the solution and apparent failure of Beer's law will result. This phenomena may be due to solute-solute molecule or solute-solvent molecule interaction. For example, this type it is the change in color of solution of potassium dichromate from orange to yellow. In dilution, the shape of absorption curve and this is shown in this figure. Due to change in color, its wavelength is changed and therefore its color is changed. As dichromate solution is diluted for a confirmatory of Beer's law, the observed absorption value included the error due to change in color of the solution as observed in the above equilibrium. In this equilibrium, deviation may also occur if solute ionizes, dissociate or associate in the solution. For example, benzyl alcohol in chloroform exists in polymeric equilibrium as shown in this equilibrium equation. As the concentration of the solution presence of large concentration of polymer, the benzyl alcohol is diluted to test the validity of Beer's law. The observed absorption value include the error due to the change in state of solute. Deviation may also occur due to the presence of impurity that fluoresce. This interface introduces an error in the measurement of radiant power of transmitted light. Deviation may also occur due to the presence of impurity. Those absorb at the absorption wavelength of test species This interface introduces an error in the measurement of radiant power of absorbed light of the sample. Deviation may occur if monochromatic light is not used. This is because the molar absorptivity depends upon the wavelength used. The plot of absorbance against wavelength for a given concentration provide lambda max value in the maximum region for a given system. The Beer's law obeyed if a spectral region is used as shown in this figure. See here, absorbance against the lambda max. If other spectral region, for example Y and Z, are used, then deviation are observed. Also, if bandwidth of radiation is large, that means light is polymeric, then the deviations are also observed. As the bandwidth becomes wider, the deviation becomes larger. If other spectral region, a single beam instrument, the fluctuation in electricity power can cause a deviation from Beer's law due to different radiant power of incident light at different setting. Deviation may occur if the width of slit is not proper and therefore it allow undesirable radiation or stray radiation to fall on the detector without passing through the sample. This cause a negative deviation from Beer's law. Deviation may occur the sample is non-homogeneous or if suspension are present in it. Also, it is desirable to test the law of concentration between 10 raised to minus 6 to 10 raised to minus 2 molar. Now, absorptivity and factors governing various measurement. A constant A of equation A is equal to ABC is called absorptivity. It is characteristic of a particular system of solute and solvent combination for a given wavelength. Its units are dependent on those chosen for B and C. The name extension coefficient or the absorption index with symbol K has been widely used for it in the past. The absorptivity is property of substance and intensive property while the absorbance is an property of particular sample and extensive property and will therefore vary with the concentration and dimension of the container. Beer's law indicate the absorptivity is a constant independent on concentration, length of path and intensity on incident radiation. It furnishes no information about the effect of temperature, the nature of solvent or the wavelength. Effect of temperature. The slight variation in temperature is found to have only secondary effect. The change in temperature causes slight variation in concentration because of the volume change and hence change in absorbance may be noticed. However, this causes no effect on absorptivity. Also, such type of effect is observed if the absorbing solute is in a state of equilibrium with the other species or with undissolved solute as in saturated solution. On the other hand, some substances exhibit quite different absorption if cooled to liquid nitrogen temperature. In practice, the absorption of an unknown is directly compared with standard at the same temperature, and for this reason, the effect of temperature can be disregarded. Now, effect of solvent. The effect of changing solvent on the absorption of a given solute cannot be generalized. Many solvents like chloroform, carbon tetrachloride, carbon disulfide, acetone, benzene, xylene, and pyridine are not suitable in region below 260 nanometer in ultraviolet. However, solvent like water, acetonitrile, saturated hydrocarbon, glycerol, methanol, isopropyl alcohol, ethyl ether are suitable in region below 220 nanometer in ultraviolet region. The absorption of an absorbing system is dependent on the wavelength used. The width of band of wavelength employed in this measurement also play very important role. It affects the apparent value of the absorptivity. Very narrow wavelength band of light, monochromatic light, give true absorption curve. Heterochromatic light of various bandwidth give unexpected and different value of absorbance. Thank you for watching.